Hi everyone, today we'll discuss another problem on Gauss divergence theorem. Verify divergence theorem taken over the rectangular parallelopiped 0 x is 0 to a, y is 0 to b, z is 0 to c. For the function f equal to x square minus yg of I plus y square minus zx of j plus z square minus xy of k. So that thing. So what is the statement of Gauss divergence theorem? Integration taken over the surface S f dot n ds equal to integral taken over the value v divergent f dv. Okay, first let me go with the divergent v. So this is the diagram I have taken along x-axis OA, OB along y-axis OC. OA is A, OB is B, OC is C. So now divergent f. Divergent f is del dot f. What is del? I dou by dou x. J dou by dou y. K dou by dou z. Dot product f. What is our f? F is x square minus yz of I plus y square minus zx of j plus z square minus xy of k. Now what the dot product says, I dot I is 1. So dou by dou x of x square minus y. J dot j is 1, dou by dou I of y square minus zx. K dot k is 1, dou by dou z of z square minus xy. So if you do partially differentiate, x square is 2x, this is 0, y square is 2y, this is 0 partially differentiating, z square is 2z, this part is 0. So we got divergent is 2 times of x plus y plus z. This is our divergent f. So what is the first part of the theorem is the left hand side or any part. First part, let us say first part integration taken over the volume v divergent f dv. So volume is 3 integral 2 constant x plus y plus z and divergent v is dv. dv is dx, dy, dz. And what we have, what he has given in the problem, what he has given in the problem, x is 0 to a, y is 0 to b, z is 0 specific. So our x is 0 to a, y is 0 to b, z is 0 to c. So what I am doing is here 2 0 to c, 0 to b, 0 to a, x dx, dy, dz plus 2 second part y dx, dy, dz plus 2 the last part z dx, dy, dz. See what the rule says, integration. Here the what the rule is not applicable because all the limit of integration is constant. So we can do separately and there is no rule that first integration should be performed by x, y or z. No, any way you can do. So x will be 2 outside, x will be x square by 2, 0 to a, y, 0 to b, z, 0 to c plus 2 y is y square by 2, 0 to b, x 0 to a, z 0 to c. 2 z square by 2, 0 to c, x 0 to a, y 0 to b. Now these two getting cancelled. These two getting cancelled. These two numerator and denominator. Here a square bc, here a b square c, here ab c square. What can you do here? We can take ABC common. So ABC common, here A is left, Here B is left, here C is left. Call it first star, 1 star. Okay, divergent V we have done. This is divergent V, divergent F, dV. This part. Done? Yeah, done. Now the second part what we have to do is the surface integral. Surface integral taken over the surface S1 F dot n ds we have to do. So what is that? So first I will go with OA. OA from OA here, this face. What is this face? Let me put the color on it. This is our face. This face. AMPN. So x equal to A and n equal to I, unit vector, unit normal vector. So what are the things we have to do? So for the face AMPN, x equal to A. X equal to A and n equal to I, unit normal. So f dot n equal to x square minus yz of I plus y square minus zx of j plus z square minus xy of k, xy of k dot product f dot. Our n is I. So I dot a is 1. We are left with x square minus yg. This is f dot n. And ds is here dy dz by n dot I. N equal to I dot I is 1. So our ds will become dy dz for this problem. Now surface integral taken over the surface f1 f dot n ds equal to double integral. What is x square? X a square minus yz of dy dz. And limit of integration is y equal to 0 to b, z equal to 0 to c. It is given. So what I am doing here is, so 0 to b, 0 to c. What I am doing here is a square I am taking outside, 0, 0 to b, dy dz. Here minus double integral yz dy dz. So now a square as it is integration. You see, separately we can do. That means we can go 0 to b y dy, 0 to c dz, minus this is y square. Oh. So this will be 0 to b dy, 0 to c z dz. Okay. Now there is no y here, please. Only dy. So this is dy is y, 0 to b, dz is z, 0 to c. This is y square by 2, 0 to b, z square by 2, 0 to c. This is a square bc minus b square c square, 2 into 2 is 4. Call it number 1. This is integration taken over the surface f dot n ds. Now for the face, second, for the face. This face, we have to go for the opposite to this face. This face. For the face, this way. For the face OCLB. For the face OC LB. A unit normal is n equal to minus I and x equal to 0. And ds is the same thing, dy dz. Same we are taking. So integration taken over the surface s to f dot n ds equal to, you see what is f dot n? You see here I is minus I. Minus I mean x is 0. Let me do y2. Let me go for that step. So f dot n. What is our f? X square minus yz of I plus y square minus zx of j plus z square minus xy of k. What is our n? Minus I. So n x is 0. Before putting 0, x square minus yz of minus I dot I is minus 1. So x is 0, minus of minus is yz. F dot n. So integration taken over the surface S to f dot n ds is double integration yz. What is ds? dy dz. And the limit of integration is x is 0 to a, y is 0 to b, z is 0 to c. Okay. So what we are doing here is 0 to b, y dy I am taking outside, 0 to c, z dc. This will be y square by 2, 0 to b, z square by 2, 0 to c. So therefore 2 is 4, b square, c square. Take it, integration taken over the surface S2. Call it 2. This phase we have done with the phase. Now for the phase 3. Now the third, for the phase, you see y, we have to go for the y. For the phase y, this part, we have to go this part. For this phase. This phase. For this phase, what will be? For the phase, you see 0 to y means y equal to b and p, p and b and. Anyway you can take. Or lb and p. Anyway you can take. So for the phase, lb and p. A unit normal for that will be n equal to j and y equal to b. And ds equal to dx dz by n dot j. So this will be dx dz. ds will be. Now we have to find f dot n. What is our f? F yz of I, y square, xz of j, z square minus xy of k. So what we have to take? Dot product with j. So here only j dot j is 1. So we are left with y square minus xz. This is f dot n. So f dot n taken over the surface S, S3 ds equal to double integration. And see limit of integration for x is, it is given 0 to a, 0 to b, 0 to c. So y equal to b, so b square minus xz. What is ds? ds is dx dz and the limit of integration is x is 0 to a and z is 0 to c. Z is 0 to c. What I am doing is I am taking b square outside, 0 0 AC dx dz minus 0 to c 0 to a xz dx dz dz or dz whatever you call. You see, this is integration having the constant limit can be separated and integrated. There is no rule to follow. Any way you can do first. Either you can go first, but limit of integration you have to be careful. But here the function also equal, that also we don't have to be. So b square x 0 to a integration of dz is a 0 to c. This will be x square by 2 0 to a. This is z square by 2 0 to c. So this is b square ac minus a square c square by 4 c square. So this is, name it C3. You see, same thing, n equal to minus j if you take, it will get plus things. Okay. Now, fourth phase. For the phase, this one, opposite to this, opposite to this one, this one, this one, this phase, the bottom one. So, what will be z? This one. Z equal to 0. No, no, y. Sorry, y no. We are going for y. Y equal to 0 and n equal to minus j. For the phase, COAM, n equal to minus j and y equal to 0 and ds equal to dx dy dz. So f dot n is x square minus yz of I plus y square minus zx of j plus z square minus xy of k. Minus j. You see, everything is 0. J dot j is minus and y equal to 0. So minus zx j dot j is minus 1. So minus times minus is plus zx. So integration taken over the surface S4 f dot n ds. Or you can say S4 or you can say COAM also you can write. No problem. So double integral. This is zx and ds is dx dz and x is 0 to a, z is 0 to c. Now when you integrate 0 to c, z dz, 0 to a, x dx. Now this will be z square by 2, 0 to c. This is will be x square by 2, 0 to a. So this will be a square c square by 4. A square c square by 4. Call it equation number 4. S4. Now for the phase, the last one. For the phase, now this phase, let me change the color. Uh, okay. For the phase, this one, the front one. Oh, oh my God. For the face, this one. This color I have to change. Let me take some dark color. Yes, this is the face. For this face. For the face, LCMP or CMPL, whatever you call. But force all should be in a cyclic clockwise or anti-clock. For the face, For the face, uh, CMPL, and unit normal is n equal to k and ds equal to dx dy by n dot k. So it is dx dy because n equal to k. Now f dot n. F dot n is our f is x square yz of I, y square minus zx of j plus z square minus xy of k. Now what we are doing? We are doing with the dot product with the k. K dot k is 1. So z square minus xy. And here z equal to c. So integration taken over the surface S5 f dot n ds equal to double integration z c c square minus xy, and our ds is dx dy, limit of integration is 0 to a, 0 to b. What we are doing here is c square outside, 0 to b, 0 to a, dx dy minus 0 to b, 0 to a, dx dy. No, c square, 0 to a dx, 0 to b dy minus this is xy. Okay. So 0 to a x dx, 0 to b y dy. So this will be c square into x, 0 to a, y, 0 to b minus x square by 2, 0 to a, y square by 2, 0 to b. So this will be a, this this will be a b c square minus this is a square b square by 4. Call it equation number 5. Now for the face, the last one. For the face opposite to this face. What is opposite to this face? Opposite to this face. This, the back of it. The back of it will be OA and B. Back of it. OA and B. OA and B. OA and B. A unit normal will be n equal to minus k and z equal to 0 and ds equal to dx dy. Now f dot n of k. You see here. Same thing. With the k, if you k, z equal to 0 minus xy into minus 1 is plus xy. Same, it is coming for every second function. So f xy. So integration taken over the surface 6 f dot n ds equal to double integration f dot n is xy dx dy, limit of integration is 0 to a, 0 to b. So this will be 0 to b y dy, 0 to a x dx. We can write anyway. Order is not important because limit of integration is constant. 0 to b x square by 2, 0 to a. So this will be a square b square by 4. Call it 6. So now integration taken over the surface S f dot n ds is equal to integration taken over the surface 1, integration taken over the surface 2, integration taken over the surface 3, integration taken over the surface 4, integration taken over the surface 5, integration taken over the surface 6. So what is what? We have to write down all. Integration taken over the surface 1. What is surface 1? A square BC minus B square C square by 4. A square BC minus B square C square by 4. A square BC minus B square C square by 4 plus S2 is, you see what is S2? What is S2? B square C square by 4 plus B square C square by 4 plus B square C square by 4. S1, S2 we have done. Now S3. S3 we have to do. What is S3? S3 is B square AC minus A square C square by 4. What is S3? B square AC minus A square C square by 4. S3. Now S4. What is our S4? What is our S4? A square C square by 4 plus A square C square by 4. Now S5. What is S5? ABC square minus A square B square by 4. ABC square minus A square B square by 4. And what is S6? A square B square by 4 plus A square B square by 4. You see this minus this they get cancelled, plus and minus, and this they get cancelled, this and this they cancel. So we are left with A square BC plus B square AC plus AB C square. So what I am doing is I am taking ABC common. So this is ABC if I take common. So what is left? From A square is gone. From A square, A is gone. So A plus B plus C. Call it 2 star. This is your integration taken over the surface S F dot n ds. And what is the formula? Divergent is del dot F dv. Are they equal? This we got ABC of A plus B plus C from 2 star. From 1 star what we have? From 1 star what we have? From 1 star this ABC of divergent V dV is ABC of A plus B plus C. ABC of A plus B plus C. ABC of A plus B plus C. What you say? Left hand side equal to right hand side. Therefore, Gauss divergence theorem is verified. Please see here, see here. The problem is looking very long and ugly problem, but it's not so. See here. He has given the function. So f is given, and you see it is a cyclic function, x square, y square, z square, minus yz, zx, this one. So statement of the Gauss theorem is this one. So we first found divergent v, then taken over the v. The limit of integration clearly he has given 0 to a, 0 to b. Just put simplify and get the answer. Now surface integral means 6 phases you have to do. For the first phase, x equal to a, n equal to either. For the phase 2, x will be 0, n equal to minus I. With that we are taking the dot product and integration. And the first phase S3, n equal to, you see, that means y-axis, on the y-axis that part, y equal to b, 0 to b, n equal to j, ds here, putting and simplifying. Then opposite to will be minus, y will be 0, ds will be dx dy. Just put it and get it. Last also along z, n equal to k, n equal to minus k. All the 6 surfaces if you add like term with opposites and got cancelled. This we got from 1 and 2 star. Gauss divergence theorem is verified. Please do subscribe if you have not done so. Share with your friends. And it's for all. And I am doing all in an easy, understandable way. If you go one through it, you can understand. Thanks for watching. Please do subscribe.